A warm welcome to you all. Thank you very much for joining us in such great numbers on LogiMAT's final day. I am delighted to present to you today the topic of efficiency in pallet handling under the premises of certain system boundaries, and also with the goal of a technology comparison. Well, as you may all be aware, the requirements concerning pallet storage and pallet planning have increasingly focused on reducing complexity in recent years already during the initial planning phase in the implementation, but also in the actual commissioning phase. At the same time, the subject of initial costs, the calculation of a quicker return on investment, and a potentially scalable cost structure has gained significant importance. And of course, the scalability and flexibility of the actual warehouse in terms of processes, throughput, and pallet storage density has gained significance for the future viability of an automated warehouse. Now there are already many long-established storage solutions for large load carriers. This can naturally be from conventional automated, but also manual forklift warehouses. The combination of AGV stackers with shuttle systems, but also, of course, stacker cranes in their most diverse designs, and various load handling devices, ranging from high-performance transport vehicles, specifically referred to as mother-child shuttle systems, and also the 2D shuttle solutions that have newly emerged in recent years, which are commonly known as four-way shuttles. The topic of system boundaries for today's presentation naturally leads us to narrow down the scope a bit, and we would like to focus today on the subject of warehouse processes, the actual warehouse technology, and the immediately adjacent warehouse pre-zone. In this context, we specifically focus on automated storage systems. And in different comparative scenarios, we take into consideration the topic of warehouse management software, the material flow control system, the actual storage and retrieval operations, which means the direct delivery to the storage technology itself, and within our cost analysis, the important subject of shelving structure. Well, to be able to perform a kind of technology comparison, certain assumptions must be made, and we had tried to keep the assumption restrictions as minimal as possible and limited ourselves to the specification of a certain installation space. And this available space was the primary requirement for the warehouse dimensioning, and it presented the challenge of comparing various storage technologies based on their energy efficiency, their storage density, the initial investment costs involved, their overall system performance, and their scalability. As already mentioned, the topic and our focus today are on various automatic storage technology. We'll look at stacker cranes with double deep storage. We'll also look at stacker cranes with channel shuttles. We would like to explore the topic of the mother-child shuttle system. These are transport vehicles which deploy channel shuttles, and the modern 2D shuttle system, which has become increasingly prevalent in recent years. The assumption is restricted to a single building geometry, specifically one defined by the clear internal dimensions and available free space, featuring a width of 23 meters, a length of 50 meters, and a clear height of 15 meters. We aim to develop a comprehensive evaluation scheme structured in the form of a network diagram, where our main emphasis will be placed on energy efficiency. Here, the energy consumption per dual operation cycle will be carefully considered. We also want to illustrate the storage density, specifically the number of pallet spaces per defined structural volume. We want to focus solely on the initial investment costs, so we'll disregard follow-up and maintenance costs today. This means it involves the purchase of the actual storage technology, the necessary software for storage space management, and for controlling material flows, but also, of course, the costs of the various racking systems. The system's overall performance, specifically the so-called inbound and outbound movements per hour, or the total number of double cycles, is carefully considered, and the important subject of scalability. What possibilities are available to me to achieve significant performance enhancements, even at a later stage without undertaking extensive structural modifications, or to effectively accommodate various altered process structures? We'll start with the double deep stacker crane. I will give a brief explanation of what this product is. It's an aisle-bound, rail-guided stacker crane that performs transport within the aisle, also handles vertical movement, and, using telescopic forks, executes the actual storage and retrieval process in the rack, as well as transfers in the pre-zone. Now, if we consider this automatic storage system with a stacker crane and double deep storage, we find that, given the existing space constraints, this technology offers limited space utilization and poor scalability. However, I have an extremely high throughput, even considering the individual pallet access situation. I have an astonishingly low investment cost, but unfortunately, due to the moved mass, a relatively high energy consumption. Let's now take this stacker crane with its double deep telescopic fork as our reference set and starting point for a further relative comparison. We then find that with this technology, we can achieve approximately 2,460 pallet storage locations. This could be realized with an input and output performance of approximately 123 double cycles. The initial investment amount in our specific case represents 100%, because it will, so to speak, serve as the fundamental starting point for any relative comparison. The same applies precisely to our energy consumption. If we now compare a stacker crane with a channel shuttle to our dimensioning for a double-deep stacker crane, we observe that the processes are quite similar. However, the transport and the actual storage and retrieval in the rack are performed using a one-dimensional channel shuttle. Let's try to derive the relative characteristics here. We'll notice that I have very good space utilization, but relatively low scalability with limited possibilities. I also have a low throughput, but a very low investment cost to implement an automated storage system. The energy consumption from the moved mass and modified storage and retrieval processes is in the medium range. So what does that mean in quantitative numbers? With our system design, we were able to realize within this available space approximately 2,755 storage positions with an inbound and outbound handling capacity of 72 pallets per hour. And compared to the dimensioning system of the stacker crane double deep, we achieve a 6% reduction in investment and a 5% reduction in energy consumption. Let's now turn our attention to the mother-child shuttle system. It is relevant to understand that a specific type of transport vehicle, referred to here as carrier, is responsible for handling the transportation within the aisle, and the actual storage and retrieval operations are also performed here by a one-dimensionally operating channel shuttle vehicle. The vertical transport itself is carried out by means of lifts. The yellow lifts at the beginning are responsible for this vertical transportation. Transport within the automated storage system is performed by transport vehicles and storage and retrieval by channel vehicles. This means I achieve excellent space utilization with this system due to its channel storage structure. However, in this scenario, we also face limited scalability, presenting a use case quite similar to stacker cranes that utilize channel shuttles. But, and this is truly the most distinctive characteristic of this particular system, it offers an exceptionally high throughput performance. However, this requires significant initial investment costs. The energy consumption resulting from the movement of individual masses is low. If I put this into relative numbers for the stacker crane double deep storage system, I get 2,755 pallet spaces with an extreme storage and retrieval performance of 200 pallets per hour. And this, of course, is tied to a high investment cost, which is 26% higher compared to the stacker crane double deep system. The energy consumption of this system decreases by approximately 18% per double cycle. In recent years, they have also been developed and introduced further scalable alternative pallet storage system solutions, specifically a 2D pallet storage shuttle system. Here too, we often speak of built-in racks, but also of silo constructions. And here we have the opportunity to create a flow rack system. We can implement storage principles of both the LIFO and FIFO classes and the actual transport within the channel, but also the aisle takes place here, with the very same shuttle system, with the same transport vehicle. The vertical transport is carried out using lifts, which come in various designs and allow for different operational variations. This means that it's possible to transport only the load carriers at an elevated level, or only the shuttle can be repositioned, or it's also possible to implement a combination of shuttle repositioning and loads. Well, how does the whole thing present itself in terms of the relative characteristics? I have a good utilization of space, but in our specific system design, it's not a very good one. This system offers very high scalability when compared to the other automated storage systems that we had previously looked at. I have extremely variable throughput capabilities, and that is the first truly interesting factor here. Not low, not medium, or high. I have variable investment costs, which I'd like to discuss in more detail shortly, and compared to all other systems, we have the lowest energy consumption. If we now consider this in quantitative terms, our system in the specific structure we designed, it provides approximately 2,548 storage spaces with a system performance of 110 pallets. The initial investment cost here is 47% higher when compared to a stacker crane system for double deep storage, and the energy consumption is 25% lower. Well, now I hope that this analysis will also raise one or two questions in your minds. And the critical point regarding the system, or rather the more intriguing aspect, is its scalability. And anyone who has studied measurement and control engineering and the intricate chaining of various controllers will realize just how complex this system can become. And in our specific case, scalability directly influences, or rather, offers the following adjustment options for the initial investment costs, the overall system performance, and the optimal utilization of space. All of these three distinct factors have a very direct influence on one another. What this implies is if I aim for a low system performance level, I will inevitably achieve significantly improved space utilization and, in our specific scenario, also attain relatively low initial investment costs. Should the client prioritize a high level of throughput performance due to optimized driving strategies and available travel routes, different process structures, and comprehensive route planning solutions, this will lead to a reduction in space utilization, and consequently, through the necessary deployment of more shuttle vehicles, the overall investment costs will inevitably rise. So placing this system in context with other systems is neither entirely trivial nor simple. And I believe the main point here is it truly comes down to your perspective, and even more for you as a customer. What perspective? What weight do you assign to each factor? If I want to create a system comparison, I am left with no alternative but to further constrain the underlying assumptions. This means not only clearly defining the available installation space, but also precisely specifying the channel storage depths. I need an identical number of article varieties that directly influence warehouse management, and I need a predetermined number of pallet storage locations. In this particular instance, I wish to concentrate exclusively on channel storage solutions. And I've come to realize that a stacker crane system equipped with channel storage, which is designated here as DCS, will entail the lowest initial investment costs, but also comes with the lowest throughput performance, and its scalability will become disproportionately expensive beyond a certain degree. If I now look at the 2D pallet shuttle system, which we refer to Axis Square, I notice that while it involves a somewhat higher initial investment costs, it allows me, over a significantly longer period and with limited additional investments, to achieve a considerably greater throughput performance. Considering the case of the multiflex, previously called the mother-child shuttle system, I initially start with an extremely high throughput performance. This in turn is also inherently tied to high initial investments. So, what would be the overall conclusion of this particular system comparison? Well, if you, whether as a customer, a planner, or a general contractor, have an urgent requirement, or your main focus is on a compact channel storage system with extremely high performance, then the mother-child shuttle system clearly presents itself as the very best solution. However, If you require an automated pallet and storage system solution that offers extremely low initial investment costs and a certain degree of flexibility in process design, and over long periods of time, considering the diverse scalability in terms of processes and storage space densities, then the 2D shuttle system will clearly emerge as the most suitable solution for you. And what's also quite interesting in the analysis is that stacker cranes in their wide range of designs with various load handling units such as single deep, double deep, one shuttle or two shuttles cover by far the broadest application portfolio, but under the premise that the throughput performance does not drift off into extreme areas, and that the storage processes will also remain clear and stable in the future, and do not diverge into an extreme state, as could perhaps be represented by a 2D shuttle system. What's relevant for you as a customer, in our view, is to find a neutral, objective warehouse technology partner and software provider who offers a comprehensive product portfolio, who is truly capable of comparing different storage systems, highlighting the specific benefits for you, and crucially not advocating for that one-fits-all solution, which, quite frankly, simply does not exist in the market. Every solution has its own valid reason for existing. It depends on your specific application or use case, and primarily on your personal weighting and your overall priorities. With that, I would like to thank you very much for your attention.